Hi everyone. Okay, before we start answering these questions, let's remember what we know about ions. So we should know that metals make positive ions and non-metals make negative ions. Metals make positive ions because they lose electrons, and we can remember that with the acronym losing is positive. Non-metals gain electrons, gaining is negative. So we're going to remember our charges on our ions with this acronym, LIPGIN. Losing is positive, gaining is negative. In this question we're being asked to describe what happens when lithium reacts with chlorine. Our command word here, describe, I'm not saying why does something happen, I'm saying what happens, and look at the note underneath. I need to answer in terms of electrons. So if I'm going to score full marks here, I need to talk about the lithium atoms changing into lithium ions by giving away an electron. At the same time, the chlorine atoms are getting an electron and turning into chloride ions. Notice the lithium has lost an electron, so it's a positive ion, and the chlorine has gained an electron, so it's become a chloride ion. And if you look at the diagram over here, you can see that the chloride has gained the electron, the little cross here, that has been lost from the lithium's outer shell. Once we've got our ions, the reaction will make a compound that will be lithium chloride, because the positive lithium will attract the negative chloride ion. Okay, question 2. We've got another ionic compound. It tells you that its name is iron pyrites, and we've got a diagram showing the arrangement of a small part of this compound. The question is asking us to determine the formula. Remember what a formula means. It tells you which elements are in a compound, and it tells you the simplest ratio that there can be between them. So I'm just going to count these two different types of atom here. I can see from the key that Fe, iron, is the black dots. I've got 1, 2, 3, 4, 6, 7, 8, 9 of those. I've got 9 iron atoms, and I'm going to do the same for the sulfur. Count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I've got 18 of these. Now I've got to look at these numbers, and I've got to think, how can I make this the simplest possible ratio? And I can see that both these numbers divide by 9. So 9 goes into 9 once, into 18 twice, which means my final answer for the formula will be 1 Fe, so I don't need a number here, and 2 S's. Okay, we should feel confident about these now. I'm going to write this down a bit bigger and remind you that these numbers from the periodic table help us to work out the numbers of protons, of neutrons and electrons. And we're remembering that that big number up the top, the mass number, this one, is equal to protons and neutrons added together. And this number here, the atomic number, is the number of protons. So I can write in straight away that there are 26 protons in an atom of iron, and then I can work out my neutrons by taking 26 away from 56, which gives me 30. 30 plus 26 makes the mass of 56. Now the electrons are always the same as the protons. So if I've got 26 protons, I've got 26 electrons as well. I can write in these numbers over here. Final question here is asking you to think about the differences between group 1 metals, in this case sodium, and transition metals, in this case iron, and a few key facts. So we should know that we could compare these metals in terms of their reactivity. So we can write a sentence that compares which is the most reactive, and we can say sodium is more reactive than iron. It's in group 1. Transition metals are also tend to be denser, so we could write about density here, because think of the demonstration of group 1 metals. They're unusual in as much as they float when you drop them into water. So group 1 metals are less dense than transition metals, in this case iron. So there's 2 good things to comment on. If you've learnt your specific facts about transition elements, you'd also know that the metals make coloured compounds. So transition metals like iron, when they join up with other elements to make a compound, those compounds tend to be coloured. This question is about group 7. We've looked at displacement in group 7, and we know that when we're looking at the group, as we write it down and we go down the periodic table, that the top of the group, the fluorine, is the most reactive element in this group. So if I'm going to decide what happens in this part A, name the product, so that's what gets made when chlorine solution reacts with potassium iodide. So we're looking at the question here. We're saying chlorine on its own is reacting with a compound, potassium iodide. The question is, can chlorine push the iodine out of the way? Chlorine is above iodine in group 7, and so we know that chlorine is more reactive than iodine. So when the chlorine reacts, it will push the iodine out of the way. The potassium iodide would react with chlorine. The chlorine is more reactive than iodine, and it would take its place and make potassium chloride, and the iodine will be pushed out of the way. We know that group 7 go round in pairs, so this will be an I2 molecule, and to make this balance, you can see I've got 2 chlorines here. I'll be making 2 of those, and I need 2 of those. But for this single mark here, we just need to name the products so we can write them down. The products will be potassium chloride and iodine. Last part, explain. Explain why chlorine is more reactive than iodine. So we know that it is true, and our answer here needs to be in terms of how easily their atoms become ions. So reactivity is all about atoms changing into ions. And remember our key fact that for group 7, they want to gain electrons. So the easier it is for an atom to gain an electron and become an ion, the more reactive it will be. And we know that fluorine here at the top is the most reactive. The smallest atom is the most reactive. And our answer here needs to be in terms of where you've got your positive nucleus and you've got shells of electrons. The attraction between the negative electron and the positive nucleus depends on the distance. So for the smaller fluorine or the smaller chlorine, they will be the most reactive, fluorine the most, then chlorine, compared to a bigger atom for iodine, because the force pulling an extra electron into the outer shell is stronger, and that's because the atom is smaller, so the outer shell is closer to the positive nucleus, which is making that attraction. So the top of group 7, non-metals, is the most reactive. Contrast that with group 1. If we were writing about group 1 here, we'd be telling the opposite story about how bigger atoms lose electrons more easily. Stick to the point, 3 clear marks, write in bullet points Why is chlorine more reactive than iodine? What are we going to say? Chlorine atoms are smaller. The distance between the nucleus and the outermost shell of electrons is smaller. Therefore, the attraction force between the nucleus and the outermost shell is stronger. And therefore, chlorine atoms can attract an extra electron into their outer shell more easily than iodine, which is a bigger atom, a bigger distance, a weaker force, and with the added impact of extra shells of electrons getting in the way of that attraction pulling on the outermost shell.